Good morning, all. Students, today we are discussing about a chapter set relations and functions. We know set is a well-defined collection of distinct objects. First type of set is of the form roster form. Second one is set builder form. Example for roster form are capital N. It is set of all natural numbers 1, 2, 3, 4, etc., which is an infinite set, contains infinite number of elements. Next one is Z, denotes integers 0, plus or minus 1, plus or minus 2, plus or minus 3, etc., which is an infinite set. Next one is Q, denotes set of all rational numbers. Its set builder form is X such that X is equal to P by Q. P, Q are integers. T is set of all irrational numbers. R is set of all real numbers. R minus set 0 is non-zero real numbers. R plus positive real numbers. C, set of all complex numbers. An empty set, null set, void set, which contains no elements, denoted by these two symbols. Very important point is set builder form of null set, set X such that X not is equal to X. Set X such that X is an even prime number other than 2 is an empty set. Null set is also a finite set. Cardinality of a set means number of elements of a finite set. Example, A is equal to set X such that X is a vowel in English alphabet. Then cardinality of A, that means n of A is equal to 5. Subset, the symbol is A subset of B. A subset of B means every element of A is also an element of B. Proper subsets denoted by this symbol. A proper subset of B means B is superset of A. A is equal to B means a subset of B and B subset of A. A is equal to set 1, 2, 3. Subsets are null set, set 1, set 2, set 3, set 1, 2, set 1, 3, set 2, 3, set 1, 2, 3. A contains n elements. Then number of subsets of A is 2 raised to n. Very important result. Number of proper subsets is equal to 2 raised to n minus 1. Next one is power set. The collection of all possible subsets is called a power set. A is equal to set 1, 2, 3. Power set of A is, it is a collection. So set, null set, set 1, set 2, set 3, set 1, 2, set 2, 3, set 1, 3, set 1, 2, 3. Number of elements in set A. Number of elements in P of A. A is a null set, no element. Number of elements in P of A is 2 raised to 0. That is only one subset. Next one, A contains single element. It is a singleton set. Number of elements of P of A is 2 raised to 1. Next one, A contains 2 members. Power set contains 2 raised to 2 members. A contains 3 members. Power set contains 2 raised to 3 members. And so on. A contains 10 elements. Then number of elements of power set is 2 raised to 10. It is 1024. We conclude that number of elements in set A is n. Then number of elements in P of A is also 2 raised to n. This is A contains n elements. Then number of subsets of A contains 2 raised to n elements. Universal set. In a set discussion, the biggest power set, the biggest possible superset of for some sets. Universal set is, in a set discussion, the biggest possible superset for some sets. Example, N is a set, natural numbers. Its superset is integers. Superset of Q. Superset of R. The final superset is complex numbers. Natural numbers, integers, rational numbers, real numbers. The biggest possible superset is complex. So complex is the universal sets for N, Z, Q and R. A question, which of the following is a set? The collection of all months of year beginning with the letter J. The collection of most talented writers of India. The collection of most dangerous animals in this world. D. None of these. Answer option A, because which is only a well-defined collection. Set is always a well-defined collection. B and C are qualities that are not well defined. Which of the following is an empty set? Option A, option B, option C, option D. Empty set means which contains no elements. Answer is option A, because no natural numbers hold 2x plus 5 is equal to 6. So, option A. Which of the following is a singleton set? Option A, option B, option C, option D. Modulus x less than A implies minus A less than x less than A. X belongs to R. Modulus x less than 1 implies minus 1 less than x less than 1. All the real numbers in between minus 1 and 1. That denotes x belongs to open interval minus 1 to 1, which is an infinite set, not a singleton set. Option B, modulus x is equal to 5, x belongs to n. The only singleton natural number hold this statement modulus x is equal to 5 is x is equal to 5. So the singleton set is option B. Another question. Which of the following set has unique subset? Option A null set, option B set 4, option C set 4 5, option D set 0. A set contains n elements. Number of subsets is 2 raised to n. First option has no elements, 0 elements. Therefore, number of subsets is 2 raised to 0 is equal to 1, a unique subset. Therefore, option A. Question is n of P of P of P of P of null set is. We know that null set contains 0 elements. Then n of P of null set is equal to 2 raised to 0 members by cardinality of power set, which is 1. Then n of P of null set. P of null set contains 1 element. Therefore, its power set contains 2 raised to 1, that is 2 members. Then n of P of null set is contains 2 raised to 2 members, that is 4. Then n of P of null set contains finally 2 raised to 4, 16 members. Note that A contains n elements. N of P of A contains 2 raised to n elements. Two finite sets having m and n elements. First set has 56 more subsets than the second. Find m plus n. Option A 7, B 9, C 11, D 13. Answer. Set A contains m elements, B contains n elements. Therefore, A has 2 raised to m subsets, B has 2 raised to n subsets. Difference between these two subsets is equal to 56. We take 2 raised to m is equal to 56 plus 2 raised to n. By a shortcut, next power of 2 is 64. Power of 2s are 2 raised to 0, 1, 2 raised to 2, 2 raised to 1, 2, 2 raised to 2, 4, 2 raised to 3, 8, 2 raised to 4, 16, 2 raised to 5, 32, 2 raised to 6, 64. Therefore, next power is 64 from 56. So, 64 is equal to 56 plus 8. This one is 2 raised to 6, 56, 8 is 2 raised to 3. Therefore, by equating these two, m is equal to 6, n is equal to 3. M plus n is equal to 9 is the answer. Option B. Answer 9. Next topic is operations on sets. First one, union A union B contains all the elements of A and B. That is x element of A or x element of B. Intersection A intersection B symbol, x element of A and x element of B. Third one is difference a minus b, x element of a and x not element of b. Symmetric difference a delta b, that is a minus b union b minus a, or a difference b union b difference a. Complement a complement is x element of u and x not element of a. Example, u is equal to set 1 2 3 4 5 6 7 8, a is equal to 1 2 3 4, b is equal to 3 4 5 6. A union b is all the elements of a and b, that is 1 2 3 4 5 6. A union B complement contains U not contained in A union B, that are 7 and 8. A intersection B is the common members between A and B, that are 3 and 4. A minus b is contained in A, not contained in B. So 1 and 2 are contained in A, not contained in B. So 1 2 A minus b. B minus A is contained in B, not belongs in A, that are 5 and 6. A delta B is union of A minus B and B minus A, that are 1 2 5 6. A complement A contains 1 2 3 4. A complement means contained in U, not contained in A. Difference between U and A are 5 6 7 8. B complement is 1 2 7 8. A complement intersection B complement, both contained in A complement and B complement. Common members between A complement and B complement, that are 7 and 8. Properties of operations. A union B is equal to B union A, like A plus B is equal to B plus A. Commutative property. A union B union C is equal to A union B union C. Associative. A union null set is equal to A, because null set contains no members. A union universal set. U is the universal set. Answer is U. A union A is equal to A. A intersection B is equal to B intersection A. A intersection B intersection C. A intersection B intersection C. A intersection U is equal to A. A intersection null set is equal to null set. A intersection A is equal to A. Fifth and 10th property called idempotency. A subset of B, A union B is equal to B. A intersection B is equal to A. A union B intersection C, distributive law. A union B intersection A union C, that A union distributed into the bracket members. A intersection B union C. A intersection B union A intersection C. A and intersection distributed into the bracket. So it is called distributive law. A complement, the whole complement is A union A complement is equal to U, A intersection A complement is equal to null set A minus A complement is A union B whole complement is equal to A complement intersection B complement, called De Morgan's law. A intersection B complement is equal to A complement union B complement. It is also called De Morgan's law. Null set complement is universal. Universal complement is null set. A minus B is also represented as A intersection B complement, contained in A and not contained in B. Here note that and, the grammar word and denotes intersection. The grammar word or denotes union. Last property, very important one, is A delta B is equal to A minus B union B minus A union B minus A intersection B, A intersection B complement minus B intersection A complement. Some questions related to these operations. Question: A is equal to set x such that x square is equal to 1, x belongs to C. B is equal to set x such that x raised to 4 is equal to 1, x belongs to C. Find A delta B. X square is equal to 1, x is a complex number. A is equal to set minus 1, 1, because minus 1 square is 1, 1 square is 1. That two complex numbers hold the statement x square is equal to 1. So set A is minus 1 and 1. B is set x such that x raised to 4 is equal to 1, x belongs to C. So holding members are minus 1 raised to 4 is 1. So minus 1. 1 raised to 4 is 1. So 1. I raised to 4. In complex property, I raised to 4 is 1. So I minus I raised to 4. Minus raised to 4 is positive. So minus I raised to 4 is 1. So x raised to 4 is equal to 1. Hold B is equal to minus 1. 1 minus I plus I. A is equal to minus 1, 1. We find A delta B. A delta B is A minus B union B minus A. Here, this diagram represents Venn diagram. First set is A, second set is B. The representations, first portion is A minus B, the middle portion is A intersection B, the last portion is B minus A. So A delta B is first portion union second portion. A minus B is null set because minus 1 and 1 contained in both the set A and B. So A minus B is clearly null set. B minus A is, some differences are there. Minus I not contained in A. So B minus A is minus I. A minus B is null set. Null set union B minus A is the set B minus A itself. That is minus I. So A delta B is set minus I. It is called a symmetric difference between A and B. Next question is a set NA, set AN, A into N, such that N belongs to A, N belongs to N. Then find N3 intersection N5, which is a previous question. N means multiples of A. Small letter n is natural number, so A into 1, A into 2, A into 3, that is A, 2A, 3A, 4A. All are multiples of A. So N3 is multiples of 3, 3, 6, 9, 12. N5 is multiples of 5, 5, 10, 15, 20. Therefore, N3 intersection N5, the intersection is 15, 30, 45, etc. First set, multiples of 3 contains 15, 30, 45, etc. Multiples of 5 is also contained 15, 30, 45, etc. So, 15, 30, 45, etc. is multiples of 15. So, it is symbolized by N15. So, answer is N15. By a shortcut, N of A intersection N of B is N of LCM of AB. LCM of 3 and 5 is 15. LCM of 3 and 5 is 15. So, N15. Question is N2 intersection N4. Then answer is N4. N2 intersection N8. LCM of 2 and 8 is 8. So, N8. N3 intersection N4. So, answer is in the LCM of 3 and 4. So, N of 12. N6 intersection N8. LCM is 24. So, N24. That is the shortcut for this question. Very important question. It is a previous question. Next question is A subset of B. Then B complement minus A complement is option A null set, option B A, option C B, option D A complement. By Venn diagram, the biggest set is superset is the universal set. Given that A subset to B, A is smaller than B, A is contained in B. So, A is here, B is this one, like India and Asia, or Kerala and India. A contained in B. B complement is the outside region of B in U. This region is B complement. A complement is outside region of A. So, all the region of B complement is contained in A complement. Therefore, there is no remaining elements in B complement minus A complement. B complement is smaller comparatively A complement. A complement is larger. So, B complement minus A complement is null set. Next one is A is equal to set 4 is to n minus 3n minus 1 such that n belongs to n. B is equal to set 9 into n minus 1 such that n belongs to n. Then option A A subset of B. Option B, A is equal to B. Option C, B is subset of A, proper subset of A. D, none of this. By induction, A implies 4 raised to n minus 3n minus 1 like members n belongs to n. By induction, take n is equal to 1, 4 raised to n, 4 raised to 1 minus 3 into 1 minus 1 is equal to 0, n is equal to 2, 4 raised to 2 minus 3 into 2 minus 1, that is equal to 9, n is equal to 3, 4 raised to 3 minus 3 into 3 minus 1 is equal to 54, 64 minus 10, 54. That means A is equal to 0, 9, 54, etc. Infinite set. B is equal to, B implies 9 into n minus 1. N is natural number. Take n is equal to 1. First member is 9 into 1 minus 1, 0. N is equal to 2, 9 into 2 minus 1 is 9. N is equal to 3, 9 into 3 minus 1 is 18. That means all the multiples of 9 with 0. B contains 0, 9, 18, etc. B contains all the multiples of 9. A contains some multiples of 9. That means A is subset of, proper subset of B. Option A. Another question is, A is equal to set 1, 2, 3, 4. B is equal to set 2, 4, 6. A intersection B, subset of C, subset of A union B. Find number of C's. Number of C's. Option A 6, option B 9, option C 8, option D 12. C is the superset of A intersection B, and also C is subset of A union B. A intersection B is clearly 2, 4. So C is 2, 4. All C's contains 2, 4. And A union B is 1, 2, 3, 4, 6. Therefore, 2, 4 contained in C, contained in 1, 2, 3, 4, 6. Therefore, possibilities of C's are 2, 4, because a set is subset of itself. 2, 4, 1, 2, 4, 3, 2, 4, 6, 2, 4, 1, 3, 2, 4, 1, 6, 2, 4, 3, 6, 2, 4, 1, 3, 6. 1, 2, 3, 4, 5, 6, 7, 8. So possibilities of C's are 8. Number of C's are 8. Its shortcut is A delta B. The difference members 1, 3, 6 between A and B. A delta B is 136. A delta B, A minus B union B minus A, 136. 3 members. Its subsets 2 raised to 3. That is 8. So take A minus B and B minus A. Its union is A delta B, contains 3 members. So its subsets is 2 raised to 3, 8 members. Therefore, by shortcut, very clearly, option C. Properties of cardinality. First one, A and B are disjoint sets, means A intersection B is equal to null set. Then n of A union B is equal to n of A plus n of B. Second one, A and B are joint sets, that is A intersection B not is equal to null set. Then n of A union B is equal to n of A plus n of B minus n of A intersection B. Third one, n of A intersection B is from second result n of A plus n of B minus n of A union B. N of, fourth one is n of A complement intersection B complement is n of U minus n of A union B. Extension of 2 is n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B minus n of A intersection C minus n of B intersection C plus n of A intersection B intersection C. Some grammatical expressions are very important for our questions. First one is either A or B. It is A union B. Both A and B is A intersection B. A but not B is A minus B. Neither A nor B, A complement intersection B complement. Exactly one of A comma B is A delta B. At least one of A comma B is A union B. Example questions are: in a group of 800 people, 550 speak Hindi, 450 speak English. How many speak both? Both means A intersection B, A and B. Result is n of A plus n of B minus n of A union B, that is 550 plus 450 minus 800. In a group means that is here A union B. So 1000 minus 800 is 200. In a group of 1000 people, 750 speak Hindi, 400 speak Bengali. How many speak Hindi only? First find out A intersection B. A intersection B is, in the previous case, also n of A plus n of B minus n of A union B. 750 plus 400 minus 1000. That is 150. By Venn diagram, it is easy from Venn diagram. N of U total contains 1000 people. Hindi intersection Bengali 150, it is center region. H minus B, only Hindi, is 600, that is 750 minus 150 is 600. Bengali only is 400 minus 150, that is 250. That is 600 plus 150 plus 250, that is 1000 itself. We have to find out how many speak Hindi only. So Hindi only is 600. In a survey of 600 students, 150 taking apple juice, 225 taking orange juice, 100 taking both. Find how many students taking neither apple juice nor orange juice. Here n of A is 150, n of B is 225, n of A intersection B both is 100. Survey means the total n of U universal set members are 600. N of A union B is equal to 150 plus 225 minus 100, the second result. So 375 minus 100 is 275. A complement intersection B complement is U minus A union B. U contains 600, A union B contains 275. So 600 minus 275 is 325. Dear viewers, subscribe my channel. Please press the bell button. Thanks for watching my video. Have a nice day.